Now we can see that from this particular example, I have that my y is equal to the square root of x. Now, recall also that my f of x is equal to y, since y is the function of x and it is this particular quantity here. Now, using my formula which I derived from my graph, I replace my first function here, which is what you still have here. Like I said, it does not change, x plus change in x. Then since my y value is not square here, but rather a square root, I just put my square root, then minus my function f of x, which is what we have here, all divided by change in x. Now, from here, we recall from basic algebra that when you have a sword, because this is a sword. Now, what you do is to rationalize, and what I mean by rationalize is taking the conjugate of the numerator here. How do you take the conjugate? You multiply both the numerator and the denominator by the conjugate of the numerator. And the conjugate of this numerator is like the inverse of the sign here, which I have replaced with plus. And so you see, multiplying both numerator and denominator by the conjugate of the numerator. And this does not change the values. It only changes the form and allows us to easily simplify a particular expression. And from here, we can see that this divided by this is simply 1. That is why I said I have not changed the value, but I'm changing the form, because 1 multiplied by a quantity is still that same quantity. So from here, we multiply through. If I multiply this by this, I get this nice looking function here, x plus change in x alone. Now, this is also basic algebra. When you multiply a quantity, the square root of a quantity by itself, by the square root of that same quantity rather, it gives you just the quantity. Just for example, if you multiply the square root of 2 times the square root of 2, you get 2 as your answer. If you multiply the square root of 3 times the square root of 3, you get 3 as your answer. So that is why multiplying these two gives me this. Now, if I multiply this by this, I get a positive answer which cancels with this negative answer when I multiply. So that is why it is not shown here. And you can try it out. If you call this A and call this B, call this A also because they are the same, and call this B. You can multiply it out by saying A minus B multiplied by A plus B rather. Sorry for that. And you can see that I have A square when I expand, and I have plus AB minus AB, then minus B square. When I expand, this is what I have. Now, the reason why this square is not here, I have explained, because you are multiplying these roots by another root of the same quantity, and that is why this disappears and we have just our nice looking quantity here. But this here cancels out this, and that is why it has not been shown here. So this is the only step I skipped for the sake of simplicity. So I'm left with a square, but in this time the square root already cancelled the square. So I have my a, which is x plus change in x, and I have my negative, which is what you are seeing here, b square. The square root already cancels out the square here, so I have my x here. So we can see that instead of having b square, I have just my b. And instead of having a square, I just have my a here, then my negative sign here. And this is all divided by this multiplied by this here, which is what I have written. My change in x multiplied by this same quantity here. And now we can see that in this step here, this is a positive x. It cancels out a negative x, leaving me with change in x in my numerator here. And we can also see here that my change in x in my numerator here cancels out my change in x in my denominator, leaving me with this nice looking quantity here. Now, if I set the limit as the x approaches 0 of change in y over change in x, I replace my quantity change in x by 0, which is what I have done here. Then I get this nice looking quantity here. And we know that change in or rather the square root of x plus the square root of x simply gives me 2 square root of x.